Hello everyone, I am Sirisha. Welcome back to Creative Math 07. Based on the thumbnail and title of this video, you have already guessed what we are going to talk about today. In this video, we will learn what a frequency distribution table is, how to create it and how to categorize data. Plus, we will discuss the difference between discrete and continuous data. Let's get started. What is frequency? We are already familiar with the word frequency. Frequency refers to the number of times particular value or category occurs in a dataset. It is a way to quantify how often something happens. Let us see an example. First, suppose, consider the following dataset of the number of books read by a group of students. So this is the given dataset. The frequency of 3 is 3 times because 3 is repeated 3 times. The frequency of 5 is 4 times because 5 is repeated 4 times. Similarly, you can write frequency for each and every observation. Now, let us move on to the next topic. What is a frequency distribution table? A frequency distribution table is a table that organizes data by showing the frequency of each value or category. It is used to present the distribution of values in a dataset. Let us see how to create a frequency distribution table. We can create a frequency distribution table for ungrouped data and grouped data. First, let us see how to create frequency distribution table for ungrouped data. For suppose, consider the following data representing fruits liked by students in a class. So this is the given data. To create a frequency distribution table, first list all the fruits, then write the frequency. That is how many times each fruit is repeated. If you observe, orange appears 2 times. In the frequency column, write 2. Mango appears 5 times. Write 5 in the frequency column. Do the same for the remaining list of fruits. This is how we create a frequency distribution table for an ungrouped data set. Now, let us continue with frequency distribution table for a grouped data. For suppose, consider the following data set representing the ages of 20 people. How to create a frequency distribution table for a grouped data? We are already familiar with the term grouped data. It refers to organizing the numbers into ranges or class intervals. First, list the intervals and count how many numbers fall into each range. Then, write those counts next to the intervals. In this example, 12 and 15 fall under the range of 10 to 19. The numbers 60, 65, 66, 69 fall under the range of 60 to 69. Similarly, you can do the same for the remaining observations. This is how we create a frequency distribution table for grouped data. How to choose class intervals depends on the dataset. You can choose the range accordingly. Here I have taken 10 to 19, 20 to 29, 30 to 39. You can also take 10 to 20, 20 to 30 range. I will explain in detail how to choose class intervals in my future videos. Now let us continue with the next topic. Let us see how to categorize data. We can categorize data into two main types, discrete and continuous. Discrete data can be either ungrouped or grouped, while continuous data can also be grouped or ungrouped. First, let us know what is meant by discrete and continuous data. Discrete data. It refers to data that can only take specific distinct values. These values are countable. Discrete data is often obtained by counting. Examples for discrete data type: the number of students in a class, the number of cars in a parking lot, the number of goals scored in a series of football matches. All these are examples of discrete data type. In discrete data, you can take only whole number values. You cannot take decimal values or fractions. The number of students in a class can be 30 or 40, but not 35.5. Now let us continue with what is meant by continuous data. It refers to data that can take any value within a given range. These values are measurable and can include decimals or fractions. Continuous data is often obtained by measuring. An example of continuous data is the height of a person. It can take any value, 5.5 feet, 5.51 feet or 5.55 feet, depending on the precision of the measurement. With this, we understand what discrete and continuous data are. Now, let's look at examples of discrete data in both ungrouped and grouped forms, as well as continuous data in ungrouped and grouped forms. Discrete data in ungrouped form. It refers to data where each individual value is listed separately. It is often used when the dataset is small and there is no need to combine or group values. Let us see some examples for ungrouped discrete data. The number of students in a class can be 25, 30 or 35, but not 25.5. You can take the example number of students who attended a class on different days. The number of books read by students All these are examples for ungrouped discrete data. Discrete data in grouped form. It refers to data that is organized into intervals or categorized, especially when the data set is large. Let us see an example. The following data is number of books read by students. If a student read 1 or 2 books, they will fall under 1 to 2 range. If a student reads 3 or 4 books, they will fall under 3 to 4 range. Similarly, you can have the remaining. You need to remember one thing. When you deal with large data sets, ungrouped data is often converted into grouped data to make analysis more manageable. Let's continue with continuous data in ungrouped form. Ungrouped continuous data refers to data where individual values are listed without being categorized into groups or intervals. This data typically consists of measurements or observations that can take any value within a range. Example, height, weight, temperature, etc. An example for ungrouped continuous data. The heights of 5 individual people, 1.58, 1.62, 1.75, so on. And you can take decimal values. Now moving to continuous data in grouped form. Grouped continuous data is usually represented in classes or intervals. It helps to analyze large data sets. Let us see an example for grouped continuous data. The following data is heights of 50 individual people. If you observe the table, you will have heights in range as one column, number of people in one column. The people who are having height 1.50 to 1.60 will fall under this group. If the height of a person is 1.78, then the person falls under 1.71 to 1.80 range. This is how continuous data in grouped form is. In this video, we have explored the concept of frequency distribution tables, how to create them, and how to categorize data effectively. We have also learned the difference between discrete and continuous data, and how each can be grouped or ungrouped with examples. I hope you found this video helpful. Please don't forget to like, share and subscribe for more.